So today's lesson is 7.5, and we're going to be working on the different properties of logarithms. There's three properties. As you can see, I can't count. This number 4 should be a number 3, so please change that. There's three properties, 1, 2, 3. The first property that we're going to cover or discuss is the product property. Now, what does the word product mean? The answer to a multiplication problem. So, product property is obviously going to involve multiplication. Now, what is it? It's really saying the log base b of m times n. So, if you have two things that you're multiplying, you could actually expand it. So, this single logarithm, you could expand it and make it two logarithms with the plus sign between them. Okay, so once again, log base b of m times n could become log base b of m plus log base b of n. Or you could go backwards. If you have two logarithms with the same base and with an addition between them, you could simply put both of them together as one single logarithm and multiply the m times n. Okay, now I know it's kind of confusing when you look at it with letters. Let's look at an actual example. We have an example right here. If you want, please jot this down somewhere. So, log base 4 of 2 plus log base 4 of 8. Okay, so we have the same exact log base 4 here and log base 4 here, but obviously we have different numbers that we're taking log base 4 of. Now, the product property allows us either to expand or to condense. In this case, it's already expanded. What we're going to do is condense it. We're going to recognize that the plus sign, I could actually put both logs together as one single log. So the log base 4 and the log base 4, I want to put it together as one single log base 4. And the 2 and the 8, I'm going to put them together as 2 times 8. Okay, now why would I do that? Because now I actually have log base 4 of 16. And now we could actually do log base 4 of 16. What's the answer to log base 4 of 16? 2. The answer is 2. So, ladies and gentlemen, we could have worked on this, log base 4 of 2, and we could have thought, okay, 4 to what power gives me 2? Oh, 4 to the 1/2 power, because that's a square root. So this is really 1/2. And then you think 4 to what power gives you 8, and it gets really complicated. In this case, the property of the product property allows you to condense it, to convert both of these separate logarithms. They have to be the same exact logarithm, right? Log base 4 here, log base 4 there. You could put them together as one single log base 4, and the numbers that you had, you put them together as a multiplication problem. So it's really condensing where you had two logarithms, converted it to one. Does that make sense? Okay, so that's the product property. Now, again, you could expand it or you could condense it. Let's go to the next one. The next one is the quotient property. What does quotient mean? Division, right? So obviously, we're going to be dividing in these cases. So again, you could expand or you could condense. In this case, if you have log base something of a fraction, in other words, log base something is something divided by something, then you could expand it and say log base b of m minus log base b of n. That's what we call expanding. Log base b of m minus log base b of n. Okay? Now you could also go backwards. If you notice that you have the same logarithm minus the same logarithm, you could take those separate logarithms, put them together, but all you got to do is put the m divided by n. So you can put m on top, n on the bottom. So you could go backwards also. If you have them separate, you could put them together as one single logarithm, m on top divided by n on the bottom. Now, when would that help you out? Well, let's say you had this expression, log base 3 of 54 minus log base 3 of 2. Now, if you try to think, okay, 3 to what power? If you're thinking 3 to what power gives you 54, okay, that's not good. You're not going to be able to do that in your head, right? Or 3 to what power gives you 2? You can't do that in your head, right? But you notice that there's a log base 3 here, a log base 3 there. It's the same exact logarithm. There is no plus between them. If it were a plus, then you'd have to condense using the product property. But the minus shows you that you could condense using the quotient property. which means that you take both of these log base 3's and condense them to one single log base 3. And all you have to do is take the first term and put it on the numerator, and the second term is the denominator. So you'd have log base 3 of 54 over 2. So using the quotient property, I'm taking these two separate logarithms that are both log base 3. It has to be the same logarithm for you to condense. Okay? The minus sign shows me that I'm going to be using the quotient property. So I take both of these log base 3's, put them as one single log base 3, I put this one over this one on top, this one on the bottom, and there's my new logarithmic expression. That's a 1 logarithm instead of 2. So we condensed it, we made it smaller, we made it nicer. And not only that, 54 is divisible by 2. That'll become log base 3, 54 divided by 2 is 27. And actually, log base 3 at 27, you could actually do that. What's the answer to log base 3 at 27? 3. That's right, 3. So being able to knowing these properties will allow you to condense and be able to get answers faster, quicker, easier, instead of struggling the way we normally would if we wouldn't have these properties. Now, the last one is called the power property. Obviously, it's going to involve an exponent. That's what a power is, right? Power. So, how does the power property work? If you have log base something of something to a certain power, that power up here, it could be moved out to the front, totally separate from the log, and you could put an n and a times right in front of it. I guess I shouldn't even write it because it's already written for us. If we look over here, it says n times log base b of m. Okay, so what is the power property? It's when you do have a power, you can move it out to the front, okay, and make it a multiplication of the log. So this is pretty interesting because the n out here is not part of the log, but the n up here is part of the log, right? Now, I know this example is probably not the best one, especially because we already know the answer to this. What's log base 3 of 9? What's the answer? 2. Okay, 2. Okay, so that's the answer. The answer is 2 because 3 squared is 9. But let me just mess with the 9 and let me show you how this property still remains true if we manipulate the 9. So check it out. We're going to have log base 3, and instead of 9, I'm going to rewrite it as 3 squared. You guys agree with that, right? Okay, now I really do have log base something of something to a power. Now the power property allows me to take the power and move it out to the front and put a multiplication between it. So it's no longer a power, now it's a multiplication sign, right? So what do I really have now? I have 2 times log base 3 of 3. Now we all know that log base 3 of 3 is what? 1. Cancels out, it's 1. So you really have 2 times 1, which is what? 2. So you see, you get the same answer. And now you're thinking, oh, then why the heck do I want to do that property? What we have to do right now is understand how to use a property because it will be essential, especially when we start solving equations, which is what we're doing today. A different type of equation than what we did last week. Any questions? Okay, guys, so here's the bottom line, and I do apologize. You're going to have to memorize all these 3 forms, all these 3 properties. You know how like back when we were solving quadratic equations, we memorized the quadratic formula? Same thing here, we're going to have to memorize it. Now, it's really easy. Think about this. Product is multiplication, and that's directly related with addition. Quotient, that's division, that's directly related with subtraction. The power property, it comes down, it becomes multiplication. And we have to memorize these so we know we could actually expand if they want us to, or condense if they want us to. So we got to be able to look at them both ways. So sometimes you'll have 2 separate logarithms. You want to make it 1 logarithm? Yeah, you could put them together as long as you multiply m times n. Or you have 2 separate logarithms with the subtraction. You could put them together as long as you put m divided by n. Or you could have n times a logarithm. You could put them together and take that n and raise it to be a power of whatever you're taking the logarithm of over here. So the more practice you get, the easier it becomes. So those are the 3 properties. In addition to the 3 properties, we're also going to be changing the base, the change of base formula. Okay? Change of base formula is straightforward and simple, and it's really useful if you don't have the Casio calculator. So for example, let's say they tell you to give you a decimal approximation or a decimal answer of log base 3 of 8. Okay, so a decimal answer, like you're thinking, okay, if it were log base 3 of 9, the answer would be 2. But we have log base 3 of 8, right? Now, even if you have the TI calculator, you can't do this, right? So a couple of years ago, we didn't have nice calculators. So right here, we'd have to use the change of base formula. So let me show you the change of base formula. It's really saying you could take any log of any base, and you could change it, but it's going to look like a fraction, to the log of the base of your choice. Yeah? So let's say you wanted to do this on the TI calculator, the Texas Instrument calculator. Texas Instrument could either do common log, which is base 10, or natural log. So if you wanted to change this to natural log, that would be ln. You could do ln up on top and ln on the bottom. And then the bigger number that's a little bit higher up goes up on top. And the base, which is further down, the 3, is going to go on the bottom, but not as base anymore, as a regular term. And that's called the change of base formula. You could actually type that into the calculator, the TI calculator, and it'll give you a decimal answer. Okay? Now, if you have the Casio, it actually has a button that you could type in to get the decimal answer straight to it. So if I wanted to find log base 3 of 8, all I would do is type in, hit this button right here, and on the screen, this will pop out, log base blank spot of blank spot. And then all you got to do is type in the 3 right in there and the 8 right in there. You should be able to hit equal, and it'll give you a crazy irrational number, a decimal, right? Now, I don't have a full class set of Casios, so it is good to know the change of base formula. So you should be able to do this even with the TI. You're either going to change it to common log or ln, because the other calculator only does common log or ln, the log base e, natural log. So you could have also changed this one to common log 8 over common log 3. And guess what? With the calculator, you should get the same exact answer as the ln. Make sense? Now, like I said, before it was really useful. Right now you're probably thinking, then why the heck do I even want to learn this formula if I could just use it? I could use this calculator. I have this button on this calculator. That is true, but what I've seen on a lot of state tests are they'll give you this expression, log base 3 of 8, and they'll tell you this, change it to base 7, right? They'll ask you to change it to base 7. The calculator doesn't even do that. Even the Casio, you can't change it to base 7. Now, in order for you to change it to base 7, you need the change of base formula. Now, how does the change of base formula work? It says that you could change your log to be any base you want. So what base do we want? Base 7. As long as we make a fraction and put the log base 7 up on top and the same log base 7 on the bottom, and then we need to fill in the rest. Now, what's the rest? The bigger number that's further up is going to go up on top as a regular number. So it's going to be log base 7 of 8. And the little base that's further down is going to be a regular number on the bottom part, a 3 down here. So if they say change it to base 7, there's my answer. It'll be a fraction, log base 7 of 8 over log base 7 of 3. Now, I've seen this before on different tests, so it's a good idea to remember the change of base formula, even though the calculator could actually find the answer to any log of any base. If they ask you to change it to a certain base, then you need this formula. Calculator can't do that for you. So on the next video, we're going to pick up on actually applying all these different properties on expressions and equations, and we'll get to that in the next video.